Let's take a look at the required hardware for this course. Of course, at the center of everything we'll be doing in this course is the ESP32 with the ESP32 Development Kit version 4 board. The one that I'm using here, and you see pictured here in this slide, is the generic version of the ESP32 Dev Kit v4, very common on eBay, on Amazon, pretty much anywhere else. There are also a lot of variations on this board produced by various manufacturers that add hardware features on this base board, like for example circuitry for getting power from a LiPo battery or charging a LiPo battery and things of that sort. And those alternative boards may have differences in the way that they lay out, especially the way that the pins are broken out. So if you do use an alternative dev kit, not the one pictured here, but something else from a different manufacturer, just be aware of those potential differences, and you can still go ahead and use it with this course as long as you understand what those differences are, especially the way that the pins are broken out, and compensate for those in the sketch and in the way that the circuitry is laid out on your breadboard. I also find useful to have at least 2 of those boards on my desk at any time so that I can run simultaneous experiments, or can have, say, one board running my main experiment and then use my second ESP32 dev kit just to figure something out without having to dismantle my original circuit. So again, I do find that having 2 of those boards available really speeds up my rate of experimentation. Of course, then you're going to need a few mini breadboards. I find that those mini breadboards, except for one experiment that you'll see later with the 7-segment displays, it's a little bit bigger in size with more wires. I find that for all of the experiments in this course, a mini breadboard was actually perfect. Just a small amount of real estate with a small number of connections makes things really clear, or lowers the risk of miswiring and having problems of that sort. So have a couple of those available. Then you're going to need wires to connect things together. I find those solid core wires, again like the ones pictured here, are perfect for the needs of this course because they produce really clean end results, clean circuits where you can see exactly where wires go because they are right on the board without overhanging other components. So nice and clear. Of course, around the ESP32, we're going to be using a variety of components that I'm going to detail next. And I should also mention that you can find the full list of these components with links to places like Amazon, where you can purchase them from, on my website at techexplorations.com/parts/ESP32. So let's check out the details. Of course, we'll be playing around with LEDs, so you're going to need at least one red LED. I recommend you buy a bunch. And with the LEDs, you also need the same number of 330 ohm current limiting resistors. I've also listed a 10 kilo ohm resistor here to use with the photoresistor, which is down at number 8 in the list, and also as a pull-up resistor for the DHT22 sensor, which is down at number 10 in this list. We are also going to experiment with RGB LEDs, and with those you also need the 330 ohm current limiting resistors for each one of the colors on the LED. We're going to need a breadboard friendly momentary button, and this button, I'll show you how to configure it with an external pull up or pull down 10 kilo ohm resistor, but also how to utilize the ESP32's internal pull up resistor. You'll need a 10 kilo ohm potentiometer to play around with the ESP32's analog inputs, a piezo speaker to make a little bit of noise. We'll do that when we are working out with the DAC, the digital to analog converter, and we'll be listening to waveforms coming out of the converter. We'll use a magnet to test one of the internal sensors in the ESP32. Then we'll need a 10 kilo ohm photoresistor with its matching 10 kilo ohm fixed resistor to measure light. A BME 280 sensor board. We'll be using that quite a lot to build environment sensing applications and little experiments. And we also need a DHT22 sensor with its 10 kilo ohm pull-up resistor. Then we'll use a DXL335 analog acceleration sensor, a 16x2 LCD module with the I2C backpack, and we'll be using this screen quite a lot in a variety of experiments to display results and display text from various sensors or various operations taking place on the ESP32. We also need a 7-segment display. This is a display that contains multiple LEDs, and each of those LEDs requires its own 330 ohm current limiting resistor. As you can see here, I've placed this circuit on a larger breadboard, but in your case, if you don't have a larger breadboard, you can just use 2 of the mini breadboards together to accommodate this circuit and make it clean. We're also going to play around with a 7-segment clock display with the I2C interface just to conserve the number of wires that we need. I'll be using this display in an experiment with the real-time clock module that you can see here in the list in number 19. We'll do some experiments with 8x8 LED matrix displays, so you can get at least one of those, but if you have 4, then we'll be able to plug them all together and create a larger display. We'll play with motors, so here I've got a small 5-volt Hobie DC motor with the DRV871 motor controller, just as an experiment of what we can do with motors in the ESP32. And I'm also going to do an experiment using a 5-volt servo motor, and here I've got it pictured with a 470 microfarad capacitor, which may or may not be needed depending on the size of the motor. The motor that I've got in the picture here is tiny, so it had no problem getting power from the ESP32, but if you happen to use something bigger, then make sure that you have this capacitor there as well on the power rail. And finally, we'll be playing around with time and date, so we'll need a DS3231 real-time clock module for that. So that wraps up the list of components that we need for this course. If you don't have all of those components, it's okay, you can still follow the course, but of course at some point you may want to do the experiments yourself so you can get them when needed. Now don't go away yet. Check out the next lecture. It's a very important lecture because in that I am going to talk about the prerequisites of this course, the things that you need to know, to be familiar with before you go ahead to explore the rest of the lectures further down. So very important. I'm also going to give you some advice on how to get the most out of the course and talk a little bit about the course structure so that you know what to expect.